Hi Year 6 Sevens. Let's take a quick look at this land parcel question. Let's summarise the question first. Someone has bought a circular piece of land 720 metres in circumference, so around. They want to divide it into different sections according to these different percentages. Let's take a look at a few simple ways that we can do this using only a trundle wheel, as that's all this person has access to. You might have already thought that you can use your knowledge of percentages to do this first part, and you're absolutely correct. Let's take a look at the 25% first of all. If we want to find 25% of our total 720, 25 over 100 times by 720 over 1. 25 times 720 is 18,000. Divided by 100 over 1 is 100. Let's do the cancelling of zeros. I can cancel two below, which means I can cancel 2 on top. 180 divided by 1 is 180 metres. That's how far he needs to measure on his boundary for his 25% section for his chickens. Let's also take a look at this 16.67% for the lettuce. $16.67 over 100 times by the total 720 over 1. 16.67 times 720 is 12,002. Divided by 100 times by 1 is 100. Now, I could use a calculator, but I don't really need to, because when we look at maths problems like this, a fraction can simply be rewritten as the numerator divided by the denominator. So 112,002 divided by 100. You can even see that the divide symbol looks a little bit like a fraction. You've got your bar, you've got your space for your numerator, you've got your space for your denominator. Anyway, when dividing by 100 or timesing by 100, it's actually a relatively simple process, or any power of 10, so 10, 100, 1000. First of all, we look at the symbol. If it's divide, we're moving our decimal to the left. Because I've got 2 zeros, I'm moving my decimal 2 places to the left. There's no decimal here, which means it must be at the end. 1, 2, 120.02. This figure here was rounded. It should be exactly 1/3, but it's not. So I'm going to round this down to what it should be, which is 120 meters. We could use this exact same process for the 12.5 and for the 8.33%, but we don't need to. Quite simply because you might have already noticed that 12.5% is half of 25%, which means that if 25% is 180 meters on the boundary, then 12.5% must be half of that. 12.5% is equal to 180 over 2, which is equal to 90 meters. You'll notice I'm putting my units in every single time so I don't get tripped up later. 8.33%. Well, that's half of 16.67%. Notice that they're not exact because I've been rounding. Which means that 120 over 2 is equal to 60 meters. If you solved it differently, you might have actually noticed that there are some equivalents. 25% is equal to 1/4. My next measure is 16.67 is equal to 1/6. 12.5 is equal to 1/8. 12.5% is equal to 1/8. And this 8.33 is equal to 1/12. Let's take a look at the 12th. We can do this by dividing our total, 720 divided by 12. 12 into 7, can't do. 12 into 72, well, that's quite simple. That's 6, because 6 12s is 72, and then the 0. So we have 60 meters, and you'll notice that that ends up being the same as what we worked out before. Same logic as before, we don't need to work out the 6 now because it's exactly double what this is, which means that the 1/6 is equal to 120, which is what we worked out previously, right here. And finally, if we look at this 1/8, we could do 720 divided by 8, but we don't need to. When dividing by powers of 2, so anything in the 2's family, 2, 4, 8, 16, 32, it's relatively straightforward if we just half it. So if we look at 720 and halve it, is equal to 360. If we then halve it again to get quarters, that's 180. And if we want 8s, we just take it one step further and halve it again. 180 over 2 is equal to 90, which is exactly what we had before. And now all we have to do is work out the quarters. Lo and behold, we go back a step and it's at 180, which is exactly where we were working with before. Beautiful. The next part of this question asks us, is it possible for him to do this without measuring every single one of his sectors? And the answer is absolutely it is, so long as he remembers his work around angle laws. So let's set up our circle. I'm going to mark in my 0. I am going to take a look at my measurements here. Now you'll notice that 720 is actually double 360. If the circumference of his land was 360 meters, 1 degree would equal 1 meter. Because it's doubled, 1 degree equals 2 meters, which means if I'm looking for 90 meters, I only need to look at half of that, which is 45. 45 degrees, 45 meters here. So I'm going to mark on 45 here. I'm going to do it one more time, and that's my 2/8. Mark down 12.5 and 12.5%. Done. I'm also going to do one more, which is my 16.67. We've worked out that was 120 meters, which is right here. Well, because 1 degree equals 2 meters, 60 degrees is equal to 120 meters. And now I have measured out 1, 2, 3 different segments. Let's take a look what that means for us. Center of my circle. Now, if I extend a line from here to here, and here to here, that's 1/8. That's one segment done. This is the next segment done. That's 2/8, which is equal to 1/4. This is one of my 16.67% done. Now, interestingly, if I do this and I extend this out here, we can see something interesting that happens. And I extend this one down here. What I have done is I've measured 1/8 and 1/8. And on the opposite side, I have a whole quarter. 2/8 make a quarter. And the reason I know this is a quarter is because this angle here is vertically opposite this angle here. The 8s here match the whole quarter on the other side. I measured the relevant distance for the 16.67 degrees. Opposite that, I extended out my lines and I have another portion that is 16.67, and finally my 8.33%. which makes this 180 meters. Note meters, not degrees. This is 90 meters. So is this. This is 120 meters. And this is 60 meters. This person has saved themselves a stack of time in measuring by use of their knowledge of angle law. There are a number of ways that you can do that. You might have done it slightly differently to me. If you've done it slightly differently, it'd be really cool if you can show your teacher the way that you did it and the way that you thought about it. So far we've used percentage and we've also used our knowledge of angles to work this problem out. Now we're going to go back to percentage, but we're also going to need to chuck in some rounding. So the next question asks if he wishes to use some mesh to fence off his each section. How much will he need? Well, let's first of all work out the distance of each of these mesh fences. We know that the radius of it, sorry, I beg your pardon, the circumference of a circle is equal to 2 pi r. We know the circumference, it's 720 meters. We know that's equal to 2 because that's a constant. Pi, we're going to make 3.14. Your calculators will have a function for this or like a button, but we're going to use this for safety's sake today, times by the radius. All we need to do now is balance it. 720, let's get rid of the 2. 720 divided by 2 is equal to 3.14. We can do that times by the radius. We can do this in our head. 360 is equal to the radius, and you'll notice that I'm now taking the 3.14 across to the side. Let's use our calculator. $360 divided by 3.14 is equal to 114.649. So let's write down 114. Now we only want up to the hundredths, which is this second digit past the decimal. So we don't need the 9, but it does help us know whether to round up or down or whichever. Because it's more than 5 or more I should say, this 4 then bumps up to 114.65, and that's meters. So his radius is 114.65 meters. He has 7 segments, 1, 2, 3, 4, 5, 6, 7, meaning 7 different fences he needs to use for a boundary, which means that 114.65 times by 7 is the amount that he'll need for the exact fencing arrangement, is 802.54. It does, however, ask how much he would need to purchase if he purchases an extra 15%. So let's take a look. 15 over 100, same as before, times by 802.55. I've actually not rounded up correctly. This should be 55 because the last digit here was a 7. So it should have rounded up this 4 to a 5. Anyway, over 100. And let's take a look at what 802.55 times 15 is. That is 12,038.21. Same logic, 12,038.21 divided by 100. Remember, numerator divided by denominator is what a fraction represents. Dividing by 100, moving the decimal 2 places to the left because it's divide. 1, 2, 120.38 meters of extra mesh, which means 802.55 plus 120.38, 3, carry the 1, 9, decimal point 229. He needs to purchase 922.93 meters of mesh in total. If you wanted to work that out differently, you could just take your 802.55 and multiply it by 1.15. All I've done there is I've conserved the full amount of the 802 in this one and multiplied it by an additional 0.15, the related decimal for 15%. And you'll see that it comes up with 922.93, which is exactly what I have here. The cost of the fencing is $20 per 5 meters. So all we need to do is divide the amount we're buying, 922.93 by 5. 5s into 9 fits 1 with 4 remainder. 5s into 42 fits 8 times with 2 remainder. 5s into 22 fits 4 times with 2 remainder. 5s into 29 fits 5 times with 4 remainder. 5s into 43 fits in 8 times with 3 remainder, 0, and fits in 6 times. He cannot buy, or this person cannot buy 0.56 of a unit. They need to round up to the next whole amount. So we need to purchase 185 units, 5 meter units of their fencing. It's going to cost them $20 per unit. So 0, 0, 0. Conserve the place of the tens by adding a 0. 2 times 5 is 10. Carry the 1. 2 times 8 plus 1 is 17. Carry the 1. 2 times 1 is 2. Plus the 1 that I carried before is $3,700. $3,700 it will cost him. If he does that, I apologize, that was off screen, but you can see I've just divided my total length of fencing by 5 to get 184. As I said before, you can't buy 0.5 of a unit. They won't let you buy it in part amounts, so that you've got to buy the extra that you don't need. 185 times by 20 is 3,700. Right. The last part of this asks you what area in meters squared is dedicated to each section. Well, we need to know, first of all, the full amount, the full area of the space. The formula for that is pi r squared. We now know that pi, we're going to use 3.14, times by my radius squared, which happens to be 114.11 squared. I'm definitely using a calculator for this one. 114.11 squared times by 3.14 is equal to 40,886. .23, because I've rounded up, meters squared. And then quite simply, it's a matter of taking my related decimal for each percentage and multiplying it by my area. And I'll just double check that my area is correct before I do it, and I've used the correct amount. I have not. I've actually used an incorrect value. It's 114.65 squared, which changes this. 114.65 squared times by 3.14 is 41,274. 0.11 meters squared. And then it's simply a matter of taking those related decimals. So if I take a look at this, 25% is 0.25, 16.67 is to 0.1667, 12.5% is to 0.125, and 8.33% is to 0.833. Now let's look at this very quickly. 0.25 times by 41,274.11 on my calculator times, delete, times 0.25 is equal to 10,318.5, 10,318.53 because I'm rounding. And if I halve that, I'll get my other amount for my 12.5. My other amount is 5,159.26, and that is that's meters squared, apologies, meters squared. And that's for 12.5%. And then finally, we can do the same logic here of 0.1667 times by 41,274.11 is equal to, so 41,274.11 times 0.1667 equals 6,880.39. And if I halve that, I will get my twelfths. So this was for 16.67%, and the related value is 0 point, and if you look at that, it's 19.197, which means that bumps up to 0.20. If you really wanted to extend yourself, you might see if you can work out how to use the area of a sector formula using what you already know. So I'll give you that up here. Make sure it's on screen. So theta is just the angle measure, which means you would have to turn your initial percentages into angles, divided by 360 times by our calculated area. I'll leave it there for now.